Hello everyone. Today we are going to talk about another Leetcode problem. Let's try to discuss it, understand it, and then code it. So the problem today is problem number 217 in leetcode.com. So the problem says, given an integer array of nums, the input is an array of integers, we have to return true if any value appears at least twice in the array. Okay, so if there is any duplicate in the array, and return false if every element is distinct. So the problem statement is quite straightforward. We have to find the duplicates, and if there is any kind of duplicate in the array, we have to return true. For example, in the first array, input array, you see that there are actually 2 ones. That means there is a duplicate, so return true. In the second example, we see that each of the numbers are actually distinct here. That means there is no duplicate. So return false. In the third example, there are like multiple duplicates. So there are multiple ones, multiple threes, multiple fours, multiple twos, okay? So obviously we are going to return true. So this is one of the problems which can be approached bottom up. That means this problem actually shows that how we can approach solving any kind of problem. We can start thinking from a very naive approach and try to improve on that. So just assume that you don't know any algorithms and data structures, but still you can find some way to solve this problem in the most naive approach. So I would, and that naive approach is also some kind of algorithm. It might not be the most efficient one. So I would suggest everyone to pause the video and think for some time how, given an integer array, how can you find duplicates in it? Okay, so I hope you have thought about the problem, and by now already you have some kind of idea about how to solve this problem. So your idea might be already efficient, or it can be the naive one. That's perfectly fine. Still, you have some idea like how to solve this problem. Even a naive solution is a solution. So I think the most common way to solve this problem that comes into anyone's mind is, if you have this input array, say 1, 2, 3, 1, what we can do is we can start reading the values. So suppose we read 1, reading the values from left to right, and then we check on the other values if it matches 1. And in this case, obviously, there will be a match, and then we return true immediately, right? Or for the second one, let's think the second input array. In that case, the input was 1, 2, 3, 4, right? Okay, so we started reading from 1, and then we checked against 2, 3, 4, and there is no duplicate there, right? Okay, so next we move on and we read the next element. The next element is 2, right? Okay, and then we check against 3 and 4, and there is no duplicate there, right? There is no 2. So we keep on doing this. Next we read 3 and then check. So the idea is like reading one element at a time and then checking every other element for the match. Okay? So that is, and if we follow this, obviously we're going to find the duplicate. Now, what is the time complexity of this algorithm? You see that we are reading each element, right? And then checking against the rest. So when we are reading 1, we are actually making n-1 searches. So there are like n-1 elements left, right? And then when we are reading the second element, we are checking against n-2 elements, right? So we keep on doing this until we reach, say, one element. And this is a series of integers from 1 to n. And as we know, this is the order of n squared, right? So that is the time complexity of this algorithm. And the space complexity is we are not actually using any extra space, right? We are just reading through it and then checking. We are not using any extra space. Space complexity is order of 1. Okay, so we got our first algorithm, which is an order of n square algorithm. Okay, so let's think about another solution. Can we improve on this? You can take a pause and think, like, from order of n square, the improvements are going to be order of, say, do we have an order of n log n algorithm or order of n algorithm? Okay, let's think about this. Okay, so if you're back again and probably you have a new idea, let's think about all the things that we know. Let's think about all the things that we know. Okay, so if you're back again, probably you have a new idea with a more efficient solution, or if you don't have it, let's discuss. So let's think about all the data structures and algorithms that we already know. So we know about different techniques, and as you know, what about if I sort the array? Say this is my input. If I sort them, then it becomes 1, 1, 1, 1, then 2, 2, 3, 3, 3, 4, 4, right? So in that case, what we can do is we can start reading, and every time we can check against my previous element, or what I can do is I can actually check against my next element. So we read, when I am actually here, I check against the next one. And if there are duplicates after sorting them, right? After sorting them, obviously the duplicates would be together, right? They would be next to each other. So if I check my next element at any place, if my current element and the next element becomes the same, then we can find the duplicate and we can return true. Even for this example, say if I sort it, then we can actually get this, right? And then we start reading from here, and I check against the next element. So every time I read an element, I check against the next element. If there is a this match, then I return true. Okay, so what's going to be the time complexity for this algorithm? We know input size is n, right? So the time complexity is going to be, and sorting takes for sorting n elements, the sorting time is n log n, right? That's the better sorting algorithms. Say if we do quick sort or merge sort, right? Quick sort is on average n log n, merge sort is n log n, and it can be, so that is the thing. And the space complexity is going to be order of 1, say. So programming languages, they usually do sorting in the background using quicksort, and quicksort doesn't use any extra space. So our algorithm now is improved in time complexity significantly. Previously, we had an order of n square algorithm. Now we have an order of n log n algorithm. Okay, so now let's think if we can improve further. you can take a pause, think about the data structures that can actually give you much better searching time or insertion time. Think about those data structures and see if you can find any which can be utilized to make the time complexity even more efficient. Okay, so I can actually now talk about a more efficient one. And the way is using hash map or hash table, right? So can you do that? So the idea is like create a hash table, and we know the hash table is like key value pair, right? So in that case, our key is going to be the inputs and value is going to be the count, right? So what we can do is we can say 1, 2, 3, 1. Initially, the hash map is going to be empty. So we can actually put 1 and then count as 1, then put 2, count as 1, then put 3 and count as 1. Next, when you read 1, the count is going to be updated to 2. So as soon as some count is updated as 2, we can just return true. Or let's think in an easier way. So when you are actually reading this last one, we are checking, before updating this, we are checking if 1 is already in the hash map, right? If it's already in the hash map, then we can immediately say that this is a duplicate. So we can immediately just return true, right? Okay. Okay, so there goes our, okay, so if I am using hash map, then you see for n elements, in the worst case, what I have to do is I have to insert into the hash map like n times, right? And we know that hash map insertion is order of 1. So n into order of 1 is order of n. So in order of n time, I can determine if there is any duplicate or not. Now about the space, for hash map, we have to use extra space. And in the worst case, you see we have to use n, like input size, extra space, right? So suppose for example 2, none of the elements are duplicated. So we keep on adding them to the hash map, but eventually we don't get any answer, but still it's using up space for all the things, right? So the space is also going to be order of n, because in the worst case, we have to take n space in the hash map. So this is a kind of a trade-off. Trade-off means for getting a much better time complexity, the space complexity is getting a little bit worse, right? Okay, so this is a trade-off which you can discuss with your interviewer. Okay, so let's try to code this problem. Okay, so first we can check if, okay, so I'm going to declare a hash map. Hash map of key is going to be integer, right? And value is going to be also integer. Okay, we name it map. And then we run a for loop to read each of the elements from the input. And then if map contains key, right? If the map is hash map already has the value input from the input, that means it's a duplicate, right? So we return true. Else what we do is we just put in the map. The key would be the input and the value is going to be so the value is going to be, so this method is, okay, so basically either we are putting a new thing in the map or we are updating it. So the thing is, every time for the value we are for any input we are putting it into the map, and so this is the map, and updating it with the value. Either this is the previous gets you the previous value. So if the already, suppose I had 1, okay, so instead of, you can just do this, you can just put 1, because what happens is as soon as you get a duplicate you just return, you never update this to 2. Okay, so that means this one is hit only if the this input value is new in the map. So if this is never hit, that means all the values were unique. So in that case, we return false. Okay. So let's think about this example: 1, 2, 3, 1. First, we get 1. 1 is not in the map, so we put it in the map with value 1 and count 1. Then we get 2. It's not in the map, so we put it in the map as 2, 1. Then we get 3, 3, 1, right? So there'll be 3 entries in the map. Now next, again, we get 1 from here, and we'll see that already we have a entry with key 1. So we will return true from here. Okay. In the second example, every time there is a new unique value, so we are going to put it into the map with entry 1, 2, 3, and 4. And then finally, so there will be 4 entries created, but never this thing is going to be executed. So we come out of the for loop and return false. Okay. So one thing, like, as you see, we have used a hash map here. And we actually really don't care about the count because we are never updating it to 2. Whenever there's as soon as there is a duplicate, we are returning true. So instead of hash map, so the count is not actually helping us here, or it's not being used for anything. So instead of hash map, we can use a hash set. So hash set is not a, it doesn't, it just stores values, not key value pairs. It's just a set, and it's such a set that there is in the hash set, you can think like it's just a set of keys. So you don't have any duplicate keys. right? Every item is unique in a hash set. This is a Java implementation. You can look if you have, obviously you can use the hash map method using the hash table from your language, but in Java, since we have hash set, I think we can use this because we really don't about the count. We just care about the okay. So the method for hash set is contains. So if at any point the set, we can call it set. The set contains the input, then we return true. Otherwise, we put the value into this is add for hash set. This is add. We add the input to the hash set. And so hash set is a set where none of the values are duplicate. Each value just has one entry. So if at some point I see that that set already has the value, that means I have found the duplicate. Okay, so after running the whole for loop, if I don't find any duplicate, I return false. So let's try to submit this. And as you see, this is pretty fast. Okay, so that's it.